Hello, my friends, and welcome to another math lesson. So we are officially all finished with multiples of 10, and now we're going to be moving on into solving two-step word problems. Now, I'm very excited about this because this is our final topic of the year. So everything after this topic will be review. All right, so let's go ahead and look at the question that's going to help guide our learning in topic 11 and then in 11-1 specifically. So our question is, how can I solve two-step word problems using diagrams and equations? Just like always, we're going to go ahead and break this down. So how can I solve two-step? So I'm going to look at this, two-step. What does that tell me? What does it mean? That means there's going to be more than one math problem that we're solving inside of each. So specifically this says 2, so that tells you that there will be 2 steps exactly, but some, as we continue through these lessons, some of these will have potentially more than 2. So you always have to watch out for that. So 2, that means we're doing more than 1. Now that means, friends, if you are only doing one step, you're only doing part of the problem and your answer is most likely going to be incorrect. So you've got to watch out for that. Now, how can I solve two-step, so more than one step, word problems? What does that give us a clue about? If it is a word problem, that means the words are going to tell us what we need to do. We're going to have to pay close attention and be detectives to look for the clues for how we solve the problem. So we are going to be solving two-step word problems using diagrams and equations. What is a diagram? A diagram is a picture of some sort. So just so you know, the diagrams that you'll be seeing in your Pearson lessons are going to be bar diagrams. So remember, that's when you have something that is broken up into multiple pieces with the total at the top. So this will be like a number. Let's say this was 11. So the way that I could break up 11 using a bar diagram, I could do 5 in this part and 6 in this part. So we're going to be seeing bar diagrams specifically, but no, if there's another strategy that works better for you, you can use that as well. This is just what the Pearson book is going to be using. And then next up, we have an equation. What is an equation? An equation is just any number sentence with an equal sign. So an example of an equation from our previous one right over here would be 5 plus 6 equals 11. So we are just going to be coming up with pictures as strategies and equations to help us solve these problems. All right, so now it is time for us to move on over into our anchor chart. So as you know, we're going to be solving these multi-step word problems. So we have several different steps that it's important for you to follow as you are solving these problems. Your first step seems pretty obvious. You're going to read and visualize your problem. So here in this example, it says, the monkeys picked 12 bananas. They ate 5, then they picked 3 more. How many bananas do they have now? So the first thing that I would do is I would read that whole problem and then I would visualize it. That means I'm going to think of a picture in my mind to help me understand what it's talking about. So here I was visualizing the little monkey. Look, there are the bananas that he ate. There are the bananas that he picked after it. So it's helping you understand what's going on in the problem. Next, write an answer statement. Now this helps guide your thinking and make sure that the work that you are solving actually gives you the information that you need. Because remember, sometimes they're going to try to trick you and they might give you more information in the word problem than you need. So if you know what your answer is supposed to look like, that will help you make sure you're using the information you need to get there. So next up, it says write a number sentence. Now this number sentence might seem like it came out of nowhere. It just says 12 minus 5 plus 3, but what did that have to do with anything? Well, my friends, all of these different numbers came from the context of the word problem itself. So this tells me that the monkeys picked 12 bananas. So I'm reading it again. I'm understanding they ate 5. So I know I'm looking for how many bananas they have now. So I know this 12 bananas will help me because that tells me how much they started with. Next, they ate 5. So if they ate, what operation do you think I would be using? If you eat something, do you have more of it or do you have less of it? You have less. So that's where we got our 12 minus 5. Those are our 12 bananas. And if they ate 5, that's our minus. Next, it says then they picked 3 more. So if it's 3 more, that means that they are getting more, which I know means addition. So that word more helped me out with my operation. And there's my plus 3. So this now takes me to my question, how many bananas do they have now? 12 minus 5 plus 3 equals how many bananas they have now. So after we've written that number sentence, and notice I had to go back to the problem. You have to go back to the problem. It's not enough to just read it once. It's just like reading our text. We want to do it more than one time so that we understand what's really going on. And then this last bit is just chunk it and solve it. We know that you can only solve one piece at a time, so you take it step by step. We had our first step here, 12 minus 5. So we chunked that, and we found that the answer was 7. And then we took our second part of that problem and we dropped it right down, plus 3, which gave us our final sum of 10. All right, so let's go ahead and do a practice problem together. So remember, my first step of my anchor chart is that I'm going to read and visualize the problem. So as I read, I'm going to be picturing in my mind what the problem is talking about. How many fewer cars have poor fuel efficiency than have either good or average? Okay, so what are we talking about here? We're talking about cars, and specifically, we are comparing their fuel efficiency. That just means whether or not they have good gas mileage or bad gas mileage. So my second step is going to be write an answer statement. So I'm going to be thinking, what will my answer look like for this problem? Well, it says how many fewer cars have poor fuel efficiency than have either good or average. So I know that what I care about are my poor fuel efficiency cars, and it's how many fewer. So it would be blank fewer have poor, and I'm just going to use FE for fuel efficiency. So I'm looking for however many fewer have poor fuel efficiency. So next, I'm going to move on to step 3, writing my number sentence. So remember, this is when I'm really going back to my question and I am delving in deep like a detective, looking for what will help me figure out the answer to my answer statement. So how many fewer, that gives me an operations clue. How many fewer cars have poor fuel than have either good or average? So this tells me that I care about how many have good fuel efficiency and how many have average fuel efficiency. But as I read this problem, I'm comparing poor to the ones that have good or average. So that actually tells me my first step. So as I look at how many have good or average, I look over here, 98 had good and 165 had average. If I'm comparing my poor to both of these together, what operation should I use to combine these two numbers? Addition. So as I'm creating my number sentence, I know that I'm going to be solving 98 plus 165. Now next, I'm going to read my problem again, And it says how many fewer have poor than have either good or average. Now that word fewer, I told you before, gives us a clue about the operation, because now at the end of 3rd grade, we know whenever we see a word that has an ER at the end, whether that's fewer, bigger, taller, shorter, what operation are we using? Subtraction, because we're comparing the difference between the numbers. And we know that a difference is the answer to a subtraction problem. So I know that after I find my answer here, I'm going to have to subtract out however many have poor. So I know I'm going to be subtracting my 224 from my poor. So I've got my number sentence. Now it's time for me to chunk and solve. So whatever strategy you would normally use is okay to use when you're solving these word problems. Now, like I said, the book and the online material is all going to show you bar diagrams. But if you don't usually use a bar diagram as a strategy, that's okay. Use the strategies that you would normally use to solve it. So the book would solve this by showing my bar diagram. So for 98 plus 165, I would have my 98 and my 165, and then I'd be solving for my total up here. So the way that I would do that, if I'm adding it, I just like to stack my numbers. 165 plus 98. For me, it helps me keep track of them, and it helps me make sure that I'm keeping all of my place values together. So here I have 5 plus 8. Y'all know me. You know my favorite strategy is counting up. So I would start at 8 and count up 5 more. 8, 9, 10, 11, 12, 13. Put my 3 down here, regroup my 1. Now I've got 1 plus 6 plus 9. I'm going to do 1 plus 9, which equals 10, and then add 6 more. What is 10 plus 6? 16. So I'm going to put my 6 down here, regroup my 1, and now 1 plus 1 equals 2. So now I've gone ahead, I've chunked it, and I have solved my first part of the steps. But remember, am I looking for how many are good or average in all? No. If I look back at my answer statement, I'm reminding myself I want to compare that to how many have poor fuel efficiency. So if I'm comparing these two numbers, if I go back to my answer statement, that reminds me, oh yeah, I still have to subtract. I have to find out how many fewer. So now I know I'm going to be dropping down that 263. So now I have 263 minus that original 224. Now I don't like to subtract side by side like that. So once again, I would stack my numbers. 263 minus 224. All right, so first of all, I'd always ask myself, that's kind of messy here, I'll fix that. 2, 6, 3. So as I'm subtracting, I always ask myself, okay, can I take 4 away from 3? No, I cannot, because 4 is bigger than 3. So I'm going to go next door, I'm going to borrow a 10. From my 6, I will leave 5 behind. I'm going to make my 3 a 13. So now I've got 13 minus 4. You know what strategy I'm going to use. Use whatever one you'd like to. I'm going to count up. So for 13 minus 4, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So my answer is 9. Next, I've got 5 minus 2. Can I take 2 away from 5? Yes, I can. 5 minus 2 equals 3. Can I take 2 away from 2? Yes, I can. It's 0. So how many fewer have poor fuel efficiency compared to our good and average? 39 cars in the study. If you have any questions, don't forget to send your teacher a message or a text or a dojo, whatever you want to use. Remember, we're here to help.